In this video, we'll be looking at another type of lipid, and those are waxes. Waxes are related to fatty acids because we've seen that fatty acids are carboxylic acids, and waxes are oftentimes esters made from fatty acids. And so we have seen in the chapter on organic chemistry that we can produce esters from carboxylic acid and an alcohol. And so fatty acids, because fatty acids are carboxylic acids, can also go through this type of reaction to form an ester, except those esters would be much larger than we normally see because the carboxylic acid, the fatty acid, is much larger than normal carboxylic acids. And so this, industrially, this is an important type of reaction because this is how we produce biodiesel. That we take fatty acids and we react them with an alcohol, typically methanol, and we produce this ester, which is called a fatty acid methyl ester, or FAME. So that these molecules can burn in a diesel engine, much like diesel fuel can. And so this is how we produce biodiesel, using this biologically derived fatty acid molecule. But anyway, in order to produce a wax, what makes a wax different from a FAME is that the alcohol is much larger. That instead of having one carbon group, we have anywhere up to 30 carbon atoms. And so the wax would have a much more hydrophobic and a much larger molecule than the biodiesel will. And so their melting points of the waxes are very high, and that's why they're almost always solid at room temperature. And so when we describe waxes, it's not just esters. That waxes can include a mixture of different hydrophobic molecules, including these esters, but also alcohols and alkanes. And waxes have a variety of purposes biologically, mostly related to waterproofing. Because they're so hydrophobic that if you build up a layer of wax, water isn't going to get through that. And so we typically see this on plant leaves, where the wax layer on the surface of the leaf prevents water from escaping the leaf so that the plant holds on to its water more efficiently. Bird feathers are another place where we see a waxy coating. But in the case of bird feathers, it's not to keep the water in, it's to keep the water out, so that the feathers are waterproofed and when it rains or the bird lands on a lake like a duck or a goose, they don't soak up all that water and sink. So in order to float, they have to keep the water out of the feathers, and they do that by covering the feathers with waxy substances, mostly made up of these fatty acid esters. And this is one of the things that happens in oil spills. If a bird is covered in oil, that hydrophobic oil will dissolve the hydrophobic wax, and so then the bird isn't waterproof anymore. And so that's why you see people going in and picking up the birds and washing the oil away, so that the waxy coating on the feathers can be rebuilt, and then the bird is waterproof again, and doesn't have to worry about getting wet. But anyway, that's the video on waxes, which are mostly these fatty acid esters.